Hello everyone, I'm Jay, your host at Everything Cloud Platform. Welcome to this session on Docker. Docker is a tool that packages software into standardized units called containers that have everything the software needs to run, including code, system tools, libraries, and settings. This allows you to run the same application on any machine that has Docker installed, regardless of the underlying operating system or hardware. We'll begin with understanding the problem Docker is trying to solve. We'll then understand what containerization is and what benefits does Docker provide. Finally, the best part of the session, hands-on real-life use case that will enable you to run Docker on your own. So let's go. Here is the agenda we'll be following for this session. We'll look at what is Docker. We'll look at what problem is it trying to solve. We'll talk about containers in a little in-depth here. And then we'll eventually move on to the hands-on lab with real-life use cases. Imagine you are in charge of setting up a server that needs to handle multiple applications for different teams. You don't have virtualized infrastructure. Everything has to run on a single physical machine. This is referring to the picture on the left. Now, all the applications on the left, the Node.js application, the MySQL, Angular, Redis, they have different libraries and different dependencies. Now you find yourselves juggling two different versions of the same software on a single system. It gets further challenging when you start scaling up the system to accommodate more applications. You'll end up dealing with hundreds of dependencies and various versions, all catering to different applications. In the computing world, this is called metrics of hell. That's what you're seeing on the left hand side. Now containers solve this challenge that you see with the metrics of hell. Now what is a container? Think about a container as a lightweight portable box that holds all the necessary ingredients for an application to run smoothly. Containers offer a way to package applications along with their dependencies, but without the need for a full-blown virtual machine. They are super efficient and don't consume as many resources as VMs. And also, containers are easily transferable between different systems, making deployment a very smooth process. To summarize, Docker created this industry standard for containers so they could be portable anywhere. Docker containers are lightweight, which means they share the machine's OS system kernel and therefore do not require an OS per application, driving higher server efficiencies and reducing server and licensing costs. And moreover, they are secure. Applications are safer in containers, and Docker provides the strongest default isolation capabilities in the industry today. Here are the benefits of using Docker. It helps solve the "it works on my machine" problem. Every developer, I'm sure you must have gone through it as well. It works on my machine, it does not work in production. When you build a container, it becomes easy to share it with another developer on any team. If you can reuse the container image or rebuild the container, a lot of work is done. A lot of problems are avoided. Second, Docker helps standardize the environment. Everything from development to continuous integration, testing, and deployment. Standardization leads to reduction in defects and increases productivity. In this day and age of version controlling code and infrastructure, Docker allows us to version control the deployable. You build the image once and can deploy it across multiple environments. Docker containers can be run on AWS, Google Cloud, or Azure, and any other public cloud providers out there. Docker containers also work easily with configuration managers like Puppet, Chef, and Ansible. And finally, it's the isolation and security that sets the containers and Dockerization apart. Docker helps you deploy multiple containers on the same host node by guaranteeing segregation of resources. The containers can use completely different tech stack without affecting each other. Security is an added benefit of isolation, granting complete control over management of applications running within the containers. Each container is allocated resources from CPU to network and cannot look into other container. Let's look at the two apps, two microservices that we will be working with throughout this demo. Now on your screen, you're seeing a VS Code window broken out in three different columns. On the first column, we have the numberwiki app. So, and in the second column, you have the mathfunctions app. So those are the two microservices we are working with, numberwiki and mathfunctions. And this is where we'll be running these two applications. So you see the functionality just to get familiar, and then we'll get into details. So what I'll do is just run the application here. So this runs on port 8081. numberwiki is running on port 8081. I'll run the mathfunctions app, and that runs on 8080. Now both of these are running. Take a quick peek. If I do a curl localhost on 8081, that should run the numberwiki. We just got the message there, right? This is an API that exposes this only one endpoint, and let's see what that endpoint really does. Or before getting into that endpoint, let's take a let's just test our math functions as well. The math functions API enables all of these endpoints. So if it, say if I want to just test one endpoint, say is prime, and say I'm doing that check on 657, yeah, the result is, say, the prime number is not, the 657 is not a prime number, and it gives you all of these details: a user message, what was the base URL that was called, the endpoint is this, host URL is this, and so on and so forth. Just something coming back from the math functions API. Now what numberwiki does is, numberwiki actually uses calls math functions to calculate all of this. So basically, for every call of numberwiki, you will see multiple calls of math functions API, and this is all to demonstrate. And in real world as well, you will have applications. Say if you think about a retail application, say a checkout service will make multiple calls to other services in the ecosystem, and that's what we are trying to demonstrate here as well. And we'll play around with Docker to build all of these applications and push to Docker registry and so on and so forth. Now let's see what our numberwiki does. So if I do a curl on localhost 8081, that's our numberwiki. Now we'll use this endpoint 1 by passing it a number, say 657, right? Pass that number. Now you see this, for the one call, it just fired all of these calls through to math functions API. It first fired the is prime, is integer, is even, get factors, get prime factors, change base, and so on and so forth. And finally, this resulted with an output that you see on your right hand side here. It returns a JSON that gives you all of these values. Input number is 657. Your result is comprised of all of these values: the number itself, and then the wiki list with all of these key value pairs. The first one is even odd, that tells you that the number is odd. Factors, it gives you details around, yeah, there are 6 factors. The number is not prime, and the factors are 1, 3, 9, 73, 219, 657. The prime factors are just these 3, 1, 3, 7, 3. And the binary, the number converted into binary looks like this. Number converted to ternary looks like this, meaning a base of 3. And say the number converted into a base of 36 looks like 819. And this is the user message, and so on and so forth. That's the setup of these two applications. We'll see a lot more around this, but just keep this functionality in mind as you look at numberwiki that runs on port 8081 and math functions that runs on port 8080. Let's get started with the hands-on lab here. Here is what we will be doing in the hands-on lab with a real life use case. We'll be playing around with the apps that we just saw, both numberwiki and mathfunctions. We'll run these containerized apps in Google Cloud Shell or any other Linux terminal for that matter, using the latest images from Docker Hub. Reason I'm going ahead with using Google Cloud Shell is it comes prepackaged with the tools that we'll be using, like gcloud, Docker Hub, and so on and so forth. You can do all of that setup in your own machine as well, and that's for a different session. We'll just use the Google Cloud Shell in this demo here. We'll build a new version of numberwiki app. Then we'll tag and push the new version to Docker Hub. And we'll see those changes reflected as we run the applications again. We'll then deploy these apps on Cloud Run. That's another form of compute. We have seen GCEs running applications in GCE in some of the other videos that we have seen previously. But in this one, we'll run the containerized apps in Cloud Run. GKE, the Google Kubernetes Engine, is the other platform compute option within Google Cloud that you can run the containerized apps in. That's for a different session. For this session, we'll demonstrate containers running in Google Cloud Run. We'll then delve into some of the SRE troubleshooting and observability related concepts, and really how do you go about seeing and building the observability and doing some troubleshooting with your containers. Here are my the apps that we are going to be playing with, the demo apps, numberwiki and mathfunctions. Here are they already on my Docker Hub. Numberwiki, if you take a look at this, it has multiple versions in here with the appropriate tags 0.1, 2, 3. It's always a best practice to say have a tag, the latest version tagged with latest, so that whenever somebody is pushing, you can just or pulling the image, you can just pull using that tag name. Right? That's numberwiki. And if I go back to my repositories, and if I pull the math functions, you will see appropriate tags in there as well. So I have this latest tag on this one. So first we will go ahead and run math functions in the Google Cloud Shell. If you are in your GCP console, you will see this activate Cloud Shell button. So go ahead and click that and you will be in this Google Cloud Shell. Just do some quick commands here. Present working directory is your home and your login name. Let's look at what Docker version do we have. We have the Docker installed and ready for use. If I run a quick few commands, just do a Docker help. That's a quick help on all the commands that are available to you. These are all the common commands, and we'll be seeing some of these here. We'll be using login to really so that we are able to use my Docker registry, right? We'll need to log in to that. We'll use the build for building the image. We'll use the Docker run to run the container from an image. We'll use some of these as you'll see, but that's a lot of good information and help that is available to you. Now we'll clear the screen here. We'll start running some container here. Let's start with running the math functions API from the latest image. Let's do a couple of commands so that you understand what's going on. So if I do a docker ps, that shows you all the containers that are actively running. There is none right now. If I do a docker ps -a, that gives me all the containers out there, even though if they are in the stop status. All right. So what we'll do is docker run that image, right? And we'll do a latest tag here. Now, see what's happening here. It said unable to find image this locally, and it started downloading the image from my public repository. Now it's available publicly, so there is no, you can absolutely run this command yourselves, and you will get the same image. You'll get the same output from wherever you are running. Right now, it says that the container is running. It tells you, like we were seeing when we demoed the app. It's running on localhost port 8080. Now, can I hit this port let's just check. If I do a curl localhost 8080, will this come up? This should, we expect that our container will come up, right? It will give us all those 6-7 endpoints that math functions occurs, but this does not work, and we'll now see why this does not work. Let's try to do a preview on this port 8080 from Google Cloud Shell. Now this will not work as well for the same reason. It just says could not connect to server. Now understand what's happening here. Our container is listening on the port 8080. Now when you try and do a curl localhost from here, from our Google Cloud Shell, or you try to do this web preview, it's not able to really get to the container's 8080 port, because it says could not connect to the server on port 8080. Ensure you have selected the correct port with an HTTP server running on it. If you think about it, it's our container that is listening on port 8080. There is nothing running on this machine on the local host server. There's nothing running on Google Cloud Shell itself. It's the container that is listening to port 8080. So we'll need to introduce modify our run command a little bit to make sure there is port forwarding from our Google Cloud Shell's machines. And at the end of the day, this is a Linux machine as well, so we'll need to port forward the 8080 port from here to the container's port 8080, and that's what we'll do by this command. We'll modify this command to introduce something like this: port 8080. So the first 8080 is the Linux machine's port that you are forwarding to the container's port. Basically, you're connecting your Google Cloud Shell's port 8080 to the container's port 8080, or part that's called port forwarding as well. So now if I run this Docker, I think I'll need to do this here and then. Now this is running, right? Now if I do a curl localhost 8080, that gives me the desired result that I want, right? That is now running the container. If I do a web preview of 8080, you will see the response coming up here as well. Take a look at this, run this command again. Now you will see this active container running because it's running here, right? So that now you see that that's your container ID. That's the image it is running. That's the initial command, main.py. It shows you some status on when was it created, status, etc. And this is the port forwarding that we set up. And look at this. That is the name Jolly called in. We did not provide that anywhere. Docker does that if you don't provide the name. So one of the best practices is to actually provide a name that you can recognize, right? This is math functions API. Maybe we'll provide the right name to it. The other problem that we'll address right here is currently this window is occupied, right? Because we ran the container in the foreground. Like you do in Bash and in Linux, you can run the processes in background. You would want to run this container image as a daemon process so that this terminal is not occupied. That's what we'll do now here. So maybe what I'll do is I'll X out of this, and at this point I'll just show you the output of docker ps command as well. Notice that this did not result in the output that you saw before. However, if you do the docker ps -a, you will see that that Jolly called in, that was the container that we ran and showing up here. So all of these are dangling unused containers sitting out there. So from time to time, what you should do is docker system prune. That just gets rid of all of these containers that are sitting out there but not running, right? So this Docker system prune just deleted all of these three customers containers, I'm sorry. And if I do a Docker ps minus a now, I don't get anything. To run the container in background as a daemon process, what you'll need to do is just introduce one more switch here, minus d. Now see this, you're back to your terminal, right? Now if you do a Docker ps, you will see that there is an active container running, and the name of the container now is whatever, alienated Nash. That's not what we want, but that's what is running right now. So that's on the same port. Now if I do a curl localhost port 8080, I'm still able to get the same output, right? Because the container is running on this port and port forwarded to the container port. So everything just works fine. It's just that now the container is running in the background, and I can very well actually run the command right from here, right? I can very well do a curl. Let me clear the screen. I can very well do a curl localhost port 8080 right here and get the same output. Let's address the name issue now. I don't like this name that Docker randomly assigns. We should have a name that we recognize. So at this point, what we'll do is we'll just terminate this container, and for that, what you can do is Docker stop, right? And now if you do a Docker ps, you don't see anything actively running. However, if you do a Docker ps minus a, you will see that container running. I will just do a Docker, you can do a Docker system prune, but let it sit right now. What we'll do is we'll run another container. We'll spin up one more container for math functions, but this time we'll assign the name ourselves. And the way you do that is if you run the same command, now we'll introduce one more switch. We'll say name math functions. That's our name. Now if you see Docker ps, the name in the name field, you have math functions here. So that's the name of your container now, and it just works fine. If I do a curl localhost again port 8080, I'll be able to get the same output. If I do a Docker ps, I see one container running. If I see a Docker ps minus a, you will see all the containers running, right? That was the previous one that we terminated. It says exited, and this is the new one that we just brought up, and the name is math functions. Let's do some quick checks on our application. Make sure that all the endpoints are working as desired. So if I do say get factors of say any number, that just runs and it'll give you, I've provided a bigger number and it does all these calculations. Now you saw that the output is just fine. All right, we are getting the output as needed. Now I'll do a few more tests, like I'll do say change base. So let's do a change base real quick here on a smaller number so that it runs quickly. If I do all right, okay, that gives you a 404, because if you see that endpoint, that is looking for two parameters there, the number that you want to change the base for and the base that you want to change it to. So if I want to make it a binary number, that just works, and now that gives you the binary. So this is working. At this point, we'll go ahead and run our numberwiki app as well. And numberwiki app, just know about that numberwiki app a little bit on what that expects. The numberwiki app, if you look at the code, the numberwiki app calls the math functions API multiple times, right, with the appropriate endpoints that we saw when we were testing math functions API. Now this expects an environment variable to be set, and that's what this os.environment with a key math functions API is the key, and the name of the math functions service is required to be passed, so that to be set when you are running the container, the numberwiki container, so that numberwiki is able to get to the math functions API. That's what we will be doing next as we start running numberwiki. To run numberwiki, we'll use similar command like we did for math functions, right? If I do a docker run, and we know that numberwiki runs on port 8081, so we'll use the port 8081. And instead of the names, now let's just change the name here. We say numberwiki, and the app is also called numberwiki with the latest tag. If we run this, yeah, again, it did not find the image locally, so it pulled from my Docker Hub. It downloaded the image. Now, if I look at Docker PS, there are two containers running. One is the math functions that we already ran, and this is numberwiki. Now, if I do a curl localhost 8081, we expect the numberwiki to run. Let's go ahead and do that. Curl localhost 8081. Yes, so the app is running. We have the app running. How about trying this endpoint? Now, notice that the first root call does not call the math functions. So this numberwiki has not called math functions yet. But as soon as we use the endpoint one, this is going to make multiple calls to math functions API. That's how the numberwiki is coded. We know the application. Now, if I do a number here, I run this. Now I run into an error. The error says, if you trace this back, the error is pointing to our code that is trying to call in the math functions API. It says it did not find the math functions API key. Notice when we went to our code, we were looking at this API functions. There is no environment variable that is set as math functions API, and that is evident from this, right? If I do an environment variables check, we haven't done anything to set an environment variable called math functions API. Now, even if I want to set that, what do I set that variable to, right? What should that variable be called? Like, what should be the value of this key that we set up in our environment variables? That's question number one. And question number two is, how do we pass this environment variable value to numberwiki container so that the code inside, when it runs, it recognizes the value that we have passed in. To pass the environment variable to the numberwiki container, let's stop the current container running that is running right now. Let's do a docker stop on numberwiki. Now, if I do a docker ps, yep, that one is gone. Only math functions is running. And of course, if I do a -a, you will see all the containers that were running. But we're not concerned with that. We'll clear all of that with docker system prune later. So for now, what we need to do is we need to run our numberwiki with one more switch. And switches are these parameters. Basically, -d is a switch or parameter, -p is a parameter, this name is a parameter. We'll need to do one more key in here. What I'll need to do is pass the environment variable. And we know that numberwiki expects a key called math functions API that has to match exactly how that is coded in the application, of course, right? Because that's the variable that the application code is looking for. And I'll need to do something like http/ and the math functions application container name. Now that's the container name, right? And along with the port 8080 that it is running on. Now this should make it work. And let's see if we are able to run this successfully. Well, the error is self-explanatory. I think we'll need to just remove the numberwiki container so that we can use. Now that is gone. If we do a docker ps, of course in ps it was not showing before as well. If I do a docker minus ps minus a, I do not see the numberwiki now anymore, and that means we'll be able to run the command that we were trying to run before. If I run this, now the container is running, and if I do a docker ps, yes, it is indeed running. The numberwiki is up, and this time with an environment variable that we have passed. Now let's see whether we are able to now avoid that error that we ran into before. If I clear the screen, I'll do a curl localhost 8081. Yeah, that one ran before as well. Let's just try and run for a number which will make the math functions call. Now we ran the math functions call, but look at this. We are still getting the same issue, and let's try and understand why this issue is still occurring. There's a concept of networking within Docker. Container networking refers to the ability for containers to connect to and communicate with each other. And that's what is missing so far. Our containers, numberwiki and math functions, are not in the same network. They are not running in any network, and that's our issue. That's why they are not able to communicate. So there are some by default there are some networks available, and you can create your networks as well, like this page is telling you to. That's what we will be doing next here. So take a look at this Docker network list. These are the 3 networks. What we can do is we can use one of these networks to run our containers in. Both the containers will need to be in the same network, and that's how the connection will be able to make them talk to each other. And that's let's go with making that happen. So for that, what we'll need to do is we'll need to kill our current containers, right? We'll need to stop both of these. So docker stop numberwiki, because we'll need to run those again in a network, right? So we'll do a docker stop numberwiki. We'll do a docker stop math functions. All right, so if I do a docker ps, there's nothing running. Docker ps minus a, there are some. Now what we'll do is let's just do a system prune, because we'll need to run again, and we'll run into the same issue that is saying that these names are already in use. So let's just do a docker system prune at this point to start fresh. Let these 3, so all the 3 containers are deleted. Now if I do a docker ps minus a, I do not have anything. Now let's do a network list. What we'll now do is we'll use our run command to include a network parameter as well. Let's create a new network of our own, and that's what we'll use in our command. So I do a docker network list to see what networks do we have available. Let's create my network. All right, so that's our new network. If I do the list again, you'll see that my network in here. Now let's run our containers. Submit the math functions. That's running. Notice that my network flag, that's important. And we'll do the same thing for our numberwiki app. Notice the same network flag here as well. We run this. Now let's take a look at our containers. Both are running. Let's do a curl localhost on 8080. That's our math functions. That's running. We do a quick test on port 81. That's running. Now it's the time for truth. Let's run this, and here we go. We have our response successfully coming from numberwiki this time. This gives us the response that we are looking for. We are done with the first 2. We have been playing with numberwiki and math functions microservices or containerized applications. We ran both of these containerized apps in Google Cloud Shell, and you could do the same in any other Linux terminals. Now Now we'll move on to building the new versions of these number wikis. Say, for example, if you want to upgrade the app or a newer version of app, how do you go about using Docker to build your image and then tag and push it to the Docker hub and then redeploy wherever you are running that app from. And we'll now migrate to using Cloud Run here. So if you go to your Google Cloud console, before you go to the console, just take a look at the documentation. I have just pointed the Google reference document on gcloud run deploy command. Everything that you do with Cloud Run, you can use gcloud as well, and we will use the terminal. We are SREs, we are platform engineers, we love terminal, so we'll do everything from Cloud Run. But notice that I have these two apps deployed on Cloud Run already, and we'll redeploy, so you won't really miss anything. You will see all these steps still. If you navigate to Google Cloud Run, you will see that these two apps are running, and we have called it mathfunctions API. Just notice that here, that is different from what we called it in Google Cloud Shell. Doesn't matter, you can call it whatever you want, but these are the two apps that are running already. And if you go to your terminal now, if you do a gcloud run services list, you will see the same two apps running, and these are running, and that's the public URL that is available, right? So if I do a curl on this, you will be able to get the same output that we have been seeing, right? That's our math functions API. If you do a curl on this, you will be able to get the response back from numberwiki. Now if I do a curl app 65, I get the same output, right? This is giving me the same output that I expected. So both the Cloud Run apps are up and running. What we'll now do is take a look at this. If I do a curl on numberwiki, that says version 0.1. Now let's address that. We'll change this version to the current version 0.3. We will rebuild our image. We'll tag it appropriately with version 4, and we'll associate the latest tag with version 0.4. Take a quick look at our Docker hub. If I go to hub.docker.com and look at our numberwiki image, currently we have like 3 versions here, if I'm not mistaken. Yeah, 0.1, 2, and 3, and the latest is tagged with 0.3 as well. So what we'll do is we'll update that version 0.1 in the code to say 0.4, and we'll rebuild the image, and we'll retag it to 0.4, and we'll also tag the 0.4 version with the latest, and then we'll redeploy this numberwiki with the latest version. That should result in reflecting this output to say 0.4. At this point, you should know what a Docker file is, because that's what Docker build uses if you're trying to build an image. That is a series of commands that Docker build uses to build your container. So there are 2 components to it. A, your Docker file, and you can look at some of these details in here. This basically defines what your work directory inside the container will be. This command is telling you to copy all the contents in your app folder into the container. This tells you to install all the dependencies that you have mentioned in the requirements.txt. So this app is a Flask based app, and these are the 5 dependencies that the numberwiki app is using, and that's what was pointed out when we were talking about the metrics from hell, that all the dependencies get packaged within a container, and that's why the container is able to run regardless of what OS you are in, because all the dependencies are built right in. And this is the entry point. Basically, you're saying python 3 main.py is the command that you run as soon as you get in. So that's your Docker file and requirements. Now if I want to move forward, what I'll do is, let's navigate to the numberwiki directory. Let me clear the screen. Let me see. Yeah, this is where all of our code is. This is the Docker file that we were just walking through, right? If I do this, yeah, that's our Docker file. And then if you take a quick peek at, say, requirements.txt, that's what we were looking at. These were the 5 dependencies we are talking about. Now what we'll do is we'll do a Docker build. Now we haven't modified the code yet, right? So currently this is showing me the last command that we ran with 0.3. What we'll now do is modify the code to change that version. Here is the code in main.py where we have the version number coded. I'll change this to version 4. I will make sure this is saved. And now we get back to our terminal to do a Docker build. Now I'll do a Docker build and look at what this command is. Basically, I'm doing a Docker build with this tag of 0.4 and I'm saying no cache. Basically, that is to say that even if there is a 0.4 version already that was built, I want it to be rebuilt again. So let's do a Docker build. Pay attention to the output that you are seeing. Everything that you are seeing, it's important for you to see. Basically, all the steps that are running. That's my first step. This is all the steps that were listed in Docker file. The 4th step is where the majority of time is taken, because you're now installing all the dependencies. Think about a Python program that you run in your laptop. If you're required to install any dependencies, yeah, you'd use pip3 install Flask API, install pandas, or whatever package that you're trying to work with. But this basically is building all of these packages pre-installed in your container image, and that's how containers become very isolated and are easy to work with on any OS. This just completed now. Now we have a couple of more steps that we'll need to do. We'll need to do a tag, Docker tag, and we want to do a version 0.4. So we are saying tag the numberwiki 0.4 to and the next path that is provided is my Docker Hub account path. So basically, this image that we have in the local that we just built in the last step, that image, tag my Docker image as well with the same thing. So let me do this, and we haven't pushed it yet. So if you look at the hub.docker.com, that really is not reflecting our 0.4 yet, because we haven't pushed it to Docker Hub yet. And I'm just refreshing my Docker Hub page so that you can see that 0.4 is not really available here yet, because we haven't pushed it yet. We'll do one more thing. Let's do a Docker push on with this 0.4 here. At this point, this 0.4 will get pushed to our Docker Hub. Once this gets pushed, we'll tag this 0.4 again with the latest tag, because that's just one of the best practices, and we'll need to push that latest tag as well to our Docker Hub. So let's this get completed. Yeah, that's just completed. And now if I refresh this, I should see a 0.4 version getting here. Right? You can very well deploy this to Cloud Run using this 0.4 tag as well. But then again, the best practice is to have your latest tag appropriately modified to point to the latest image, and that's what we'll do here. So we'll do a Docker tag, and same 0.4 image, I'll tag it with latest as well, and we'll do a Docker push for the latest tag as well. Let this get pushed. Okay, all right, so this is completed, and if I do a refresh here, now I have the latest tag that is modified. Now this is saying few seconds ago. Notice that our applications and our microservices in Cloud App are in Cloud Run are still running as is. We haven't really redeployed the latest version yet. So if I do a curl on numberwiki, I still see version 0.1 because we haven't redeployed. Now let's do a this is the command run deploy. Take a quick help and you will see all of these parameters. Now you can do a lot with this. We will just use some of the basic ones here. We'll need to use the image here, and there are some specific ones that we will use here to really get the bare minimum done. So let's do this. Let me do a run deploy, and that's the command that we will be using. Now notice that the way this command is structured, it's using some variables here. So we'll need to make sure that the variables are appropriately set up. It's using the app name and in a variable called app. For the image, it's using a variable called image. For port, you directly have the port called out here. For region, it's using a region. Cloud Run microservices run in a specific region. We are saying this is platform managed. We are so this is not secure yet, but just for demo purposes, we are allowing all unauthenticated invocations as well. Now this is important. Remember how we set up the environment variables, and we passed the environment variables when we were running the numberwiki in our Cloud Shell? Well, this flag, this parameter set env vars does the same thing. We are setting the mathfunctions API environment variable with the value. Now notice the value in here. The value of this is different. It's passing the Cloud Run API URL for the mathfunctions API to this. So before we submit the command, we want to validate that our variables are set up correctly. The variables are app, image, and region. We want to make sure they are set up correctly. We are saying app equals to numberwiki. And now if I do an echo, yes, I have it. I do an app on region, I have that set up right. Let me do an echo on image. So there is nothing. And where do I get the image name from? That's my image name. That's the image. And what is the tag? Yeah, the tag is latest. So my image name is going to be image equals to this. Yep, yeah, that's my image. Okay, so I have all the variables now set up. Now if I do a gcloud run deploy $app, I should be able to get this redeployed. Watch this output. This is important as well. Basically, this is redeploying that service, and it says that all the traffic has been routed to the newer version of this, and our URL does not change. Now if we do a curl on this URL, you see that version 4 coming up. So that tells you that you were able to successfully redeploy the app on Cloud Run. Let's spend a few minutes on SRE troubleshooting and observability as called out in the last bullet here. For observability, there is a separate video on building observability on Cloud Run. Please watch that video, and I'll provide the link here right on the screen. For a little bit of troubleshooting, here is how, if you're troubleshooting your containers from command line, here are a few commands that you should be able to use to do some troubleshooting with your container issues. Like with any other application software, you will always run into some or the other issues. When troubleshooting issues with containers, there are a couple of commands that you should be aware about. So say your containers are running. Take a quick peek here. Both the containers are running. Say if I want to log into that container, just to see if I want to explore what's going on within the container, if you want to log into it, there's this command that you can use: docker exec -it, name of the container, and then the starting with, like what will you use to log into the container. If you run that command, if you now see do an ls, notice that you are seeing all the files that we used to build the container in the first place. Here is our application code for a quick reference. All of this code you are seeing available right within the container. So if I just say cat docker file, yeah, that's the docker file that we use to build the application in the first place, right? So that's how you get into a container. And say if you want to get the logs of that are getting logged in the container, these are the same logs that you will see in cloud logging as well. But a quick from the docker command, you will be able to do a logs docker logs container name, and you'll be able to get the last logs, right? Currently, say I ran the numberwiki for 678. Maybe let's do a curl on localhost 8081 slash say 980 897. So this should hit a lot of requests for math functions, and see that 897, this is showing up here. So that's how you go about doing a little bit of troubleshooting and looking at the logs right from your terminal from the container. Here's the recap of what we did today. We got introduced to Docker. We discussed the issues with dependency matrix hell. We understood what containers are. We discussed the benefits of of containers, and finally we did a lot of hands-on lab with real-life use cases using the demo apps numberwiki and math functions. Well, that brings us to the end of this video on Docker. Hope you like the content. Well, if you really did like the content, please do subscribe the channel and hit the bell icon to get notifications when new videos are posted. If you're genuinely interested in learning all the foundational skills we have been looking at on Everything Cloud platform, stick around and follow along all the videos that are posted. I'm sure you had a wonderful time today in this video, and I'll see you in the next session.